All right, let's just jump right into it. Welcome to today's Explainer, where we're going to demystify one of the most complex yet absolutely crucial realities facing tech leaders today. We are talking about enterprise AI unit economics. By now in 2026, the landscape of deploying large language models has completely shifted. Scaling AI, it's no longer just about, throwing the absolute most expensive hardware at a problem. The days of unlimited cloud budgets are totally over. It's now a strict, rigorous exercise in unit economics. So today, we are opening up the self-hosting survival guide. Let's get started. I bet you've heard a conversation exactly like this one happening in nearly every CTO's office recently. Someone from engineering looks at a cloud GPU rental, say $2 an hour, they compare it to API token costs, and bam, they conclude that building a self-hosted server is for sure the cheaper route. Well, as the data actually shows, they are more likely wrong. And honestly, getting this wrong, it can cost hundreds of thousands of dollars, not to mention months of totally wasted engineering time. To put this in perspective, enterprise API spend for AI right now has hit a staggering $8.4 billion. So how do we make the right call without falling for the illusion of cheap GPU rentals? So here is our data-driven roadmap for today. We're going to cover the API versus self-hosted reality, the hidden cost of infrastructure, the great GPU battle, the quantization cheat code, and finally, building hybrid Kubernetes solutions. All right, part 1, the API versus self-hosted reality. Okay, so the very first major debate is figuring out when it actually makes financial sense to manage your own hardware as opposed to just making a super simple API call to OpenAI, Anthropic, or Google. And the absolute most crucial thing to remember is this number right here, 256 million. So what is it? That is the estimated monthly token break-even point where self-hosting actually starts making financial sense against frontier models like GPT 5.4 or Claude Sonnet 4.6. Think about that for a second. That is roughly 8.5 million tokens every single day. If your workload is consistently running below that massive volume, going the managed API route is going to win out in almost every single cost scenario. But wait, the math gets even crazier when you look at budget tier APIs. If you're comparing self-hosting against a budget model like DeepSeek V4, which, by the way, charges a mere 14 cents per 1 million input tokens, that break-even point for self-hosting stretches way out into the billions of tokens per month. At that kind of scale, you aren't just running some startup workload anymore. You are literally running infrastructure at the scale of a major tech platform. Against budget APIs, self-hosting almost never wins on cost. The one big exception? If you're in a highly regulated industry, like healthcare or finance, where HIPAA mandates, GDPR data residency, or attorney-client privilege literally forces your hand to keep all that data strictly in-house.
Which brings us to part 2, the hidden costs of infrastructure.
So let's say you do decide, or you're forced to self-host. We absolutely have to talk about the invisible expenses. These hidden costs easily make self-hosting 3 to 5 times more expensive than that raw $2 an hour GPU rate you saw advertised. Teams systematically ignore these factors. First up, engineering labor. Maintaining a self-hosted LLM takes about 10 to 20 hours a month minimum. That's between $750 to $3,000 just in labor. Second, model update cycles. New versions drop all the time, and it costs roughly $12,000 a year in engineering time just to retest and redeploy them. Third, GPU utilization waste. Enterprise workloads are bursty, right? They sleep at night. Well, your GPU build definitely doesn't. Fourth, power and cooling overhead in data centers actually runs about 1.5 to 2 times the rated power of the GPU itself. And finally, hardware depreciation. An enterprise H200 loses about $833 in value every single month. You have to calculate the total cost of ownership here, folks, not just the raw compute rental. All right, part 3, the GPU battle. H100 versus the rest. If you are self-hosting, think of your hardware choices kind of like a fleet of vehicles. First, we have the NVIDIA H100. This is the premium bullet train. It's expensive, yes, but it pushes massive bandwidth. It's totally ideal for models over 30 billion parameters where you have super strict real-time latency requirements. Think of an interactive customer service bot. Next up is the NVIDIA L40S. Think of this as the versatile hybrid. It doesn't have the brute force of the H100, but the price-to-performance ratio is honestly incredible for smaller models under 13 billion parameters, especially for vision language tasks. And finally, the NVIDIA A100, the legacy cargo ship. It might be a bit older, but at sub-$1 hourly rates, it offers unmatched value for massive offline batch inference jobs where a slight delay in that first token just doesn't matter. Now, you might be wondering, why did we match those specific GPUs to those specific tasks? Well, it all comes down to memory bandwidth. This is literally the speed at which model weights move from the VRAM into the tensor cores. When you are running AI inference, your true bottleneck is almost never raw processing power. It's memory bandwidth. Optimizing this pipe is exactly how you drive down your ultimate metric, which is, of course, the cost per token.
Moving right along to part 4, the quantization cheat code.
Okay, get ready, because this is the absolute aha moment of this explainer. Quantization is basically the software cheat code of shrinking model weights, say taking them from a bulky, high-precision 16-bit decimal format down to a much simpler 8-bit or 4-bit integer format. Look at this comparison for an 80GB H100 GPU. If you run standard BF16 precision, the model weights take up so much room that your KV cache, the memory used to track individual user conversations, only has enough room for 4 concurrent users. 4. But if you shrink those weights down using int4 quantization, you free up so much memory that your KV cache can suddenly serve 47 concurrent users. That is a 12x increase in serving capacity from the exact same physical piece of hardware. Quantization isn't just about making things faster, it is all about massive concurrency.
And the financial impact of that concurrency, it's huge. On an H100, standard BF16 costs about $28.73 per million tokens. INT4 drops that all the way down to $10.69. Wow, right? But, and this is a big but, the data actually shows that FP8, which sits right in the middle at $19.74, is often the safest sweet spot. Why is that? Well, because while INT4 is incredibly cheap and fast, benchmark testing shows it actually severely degrades code generation scores and complex reasoning. So FP8 gives you a really massive cost reduction with almost zero measurable accuracy loss. It's the Goldilocks zone.
Finally, part 5, building hybrid Kubernetes solutions.
So we have the economics figured out. The hardware is selected, the software is optimized. How do we actually deploy this thing into production? The sheer elegance of this Kubernetes setup is in its simplicity. Step 1, you create a persistent volume claim using robust replicated block storage. Step 2, you deploy the highly efficient VLLM inference server right alongside your Hugging Face token. Step 3, you just dynamically scale up and down as needed. Here's the kicker. By using persistent storage back in Step 1, when your pod inevitably restarts, it doesn't have to re-download a massive 50GB model from the internet over and over. It's already cached locally. That means your downtime is virtually zero.
And this all brings us to our ultimate 2026 strategy, the hybrid architecture. You see, you don't have to choose just one path and risk vendor lock-in. The winning strategy right now is using a gateway router. You dispatch your routine, everyday tasks to cheap managed APIs like DeepSeek or Gemini Flash. But when a request comes in containing sensitive, regulated data, your router automatically dispatches that specific request to your highly optimized, self-hosted Kubernetes VLLM cluster. You essentially get the cost efficiency of the cloud with the strict security of on-premise hardware. It's the best of both worlds.
Which leaves us with this final, absolutely vital question to ask yourselves and your engineering teams today. Are you actually paying for AI inference, or are you just paying to keep idle GPUs warm? As we've seen throughout this explainer, self-hosting is incredibly powerful, but really only if the math, the volume, and the hardware optimizations genuinely support it. You have to dig into your total cost of ownership, track those token volumes rigorously, and build architectures that give you real flexibility. Because honestly, that's how you survive and thrive in the modern AI economy. Thanks so much for joining me on this explainer, and I'll catch you next time.